Have you ever pondered the shape of our world? Could it be flat, contrary to the popular belief that it's spherical? These questions may seem eccentric, even absurd in the 21st century, yet they form the basis of an ongoing debate that has gained momentum in recent years. Our story begins in the ancient world, where the concept of a flat Earth was widely accepted. Ancient cultures, from the Egyptians to the Chinese, believed that the Earth was a flat disk floating in the ocean. This idea was not challenged until the classical Greek period, when philosophers like Pythagoras and Parmenides proposed the idea of a spherical Earth. Fast forward to the Middle Ages, and most educated people in the Western world accepted the Earth's roundness as fact. However, in a twist of irony, the age of the internet and social media has seen a resurgence of the flat Earth theory. A growing number of individuals are challenging the established scientific consensus, claiming that the Earth is, in fact, flat. This has led to a fascinating and at times heated debate between proponents of the flat and spherical Earth theories. On one side, we have the flat earthers, who argue that our perceptions and everyday experiences suggest a flat, not spherical, Earth. They believe that the idea of a round Earth is a grand conspiracy perpetuated by governments and space agencies worldwide. On the other side, we have the proponents of the spherical Earth theory, who base their arguments on centuries of scientific observations and empirical evidence. They point to phenomena such as the curvature of the Earth's horizon, the shape of its shadow during lunar eclipses, and images of the Earth taken from space as proof of its roundness. As we prepare to delve deeper into both viewpoints, it's essential to remember the purpose of this exploration. This isn't about ridiculing or dismissing anyone's beliefs. Rather, it's about understanding the arguments, the evidence, and most importantly, the people behind these theories. So as we dive into this intriguing debate, remember to keep an open mind. Or flat earthers, as they're known, have a unique perspective on our world, but what exactly is the flat Earth theory? In essence, the flat Earth theory posits that our planet is not a sphere, as mainstream science suggests, but a flat plane. This idea is championed by a group known as the Flat Earth Society. Formed in the early 20th century, they have a remarkably different interpretation of our world and its physical properties. So what does this flat world look like according to them? Well, imagine a disk, the North Pole at the center, and a wall of ice, what we call Antarctica, forming an edge around it. This disk-like Earth, they believe, is the true shape of our planet. But what about gravity, you ask? A force that pulls everything towards the center of mass. It's one of the significant reasons we believe in a spherical Earth. However, flat earthers have a different take on it. They propose that the Earth is constantly accelerating upwards, propelled by a mysterious force they call universal acceleration. This upward motion, they argue, creates the illusion of gravity. Then comes the question of images and experiences that seem to contradict their theory. Photos of the Earth from space showing a round planet, for instance. Flat earthers attribute these to elaborate hoaxes, sophisticated CGI, or lens distortion. They argue that our personal experiences, like viewing a ship disappear over the horizon, can be explained by perspective and the limits of human vision. This theory, while at odds with mainstream science, has attracted a following. It challenges the way we perceive our world and asks us to question established truths. While many dismiss it as pseudoscience, it continues to intrigue, sparking debate and curiosity around the globe. A fascinating perspective, isn't it? But there's another side to this story. Since ancient times, many have believed the Earth is spherical. Let's uncover the reasons behind this belief. The spherical Earth theory, a cornerstone of modern scientific understanding, posits that our planet is not a flat plane, but a sphere. This concept was first proposed by the ancient Greeks, with philosopher Pythagoras often credited as the originator of the idea. It wasn't until the 3rd century BC, however, that Hellenistic astronomer Eratosthenes provided the first empirical evidence supporting this claim. By measuring the angles of shadows in two distant cities, he accurately calculated the Earth's circumference, a feat only possible if the Earth was indeed spherical. Fast forward to the age of exploration, and maritime navigators further bolstered the spherical Earth theory. They observed how ships slowly disappeared over the horizon, hull first and then the mast, a phenomenon explained by the curvature of the Earth. This effect, known as sinking ship effect, could not be accounted for in a flat Earth model. In the realm of physics, the spherical Earth theory elegantly explains gravity, a force that pulls objects towards the center of mass. On a spherical Earth, gravity pulls everything towards the middle, creating a downward force that feels the same whether you're in America, Asia, or Antarctica. This uniform experience of gravity across the globe is a strong indication of a spherical Earth. Lastly, the changing seasons provide another compelling piece of evidence. The Earth's tilt in relation to its orbit around the Sun results in varying amounts of sunlight reaching different parts of the globe at different times of the year. This phenomenon, which gives us our seasons, only makes sense if the Earth is spherical, as it allows for the Sun's rays to hit different latitudes at different angles. Two compelling arguments, each with its own set of proofs, so where does that leave us? It's a clash of theories, each with its own set of believers, but what happens when they come face to face? In the grand arena of scientific debate, where ideas are the swords and shields, the flat Earth theory and the spherical Earth theory are two gladiators that never fail to stir the crowd. Their battles are fierce and their arguments passionate. But how do these debates play out? And what are the most common points of contention? The flat Earth proponents often point to their sensory perception. They argue we see a flat horizon, not a curved one. If the world were truly a sphere, wouldn't we see a curve? They also criticize the idea of gravity, questioning its very existence. If gravity pulls everything towards the center, why doesn't water flow downwards on a sphere? On the other hand, the spherical Earth advocates draw upon centuries of astronomical observations and scientific evidence. They retort the curve of the Earth is visible from higher altitudes, and as for gravity, it's the very reason why water doesn't flow downwards on a sphere. It pulls everything equally towards the center, creating the illusion of a flat surface. The rebuttal from the flat Earth theorists is often to question the authenticity of these observations and evidence. Are we simply to believe what we're told without questioning, they ask? The spherical Earth supporters counter this with a challenge. Why not conduct your own experiments, they suggest. Observe the way ships disappear over the horizon, hull first, or how different constellations are visible in the northern and southern hemispheres. And so the debate rages on: science versus perception, evidence versus skepticism, each side refuting the other, each side presenting its own set of arguments and counter-arguments. The debate continues with neither side willing to back down. But what can we take away from all of this? Regardless of which side you lean towards, one thing is clear: the pursuit of knowledge is a journey, not a destination. And in this journey, questioning and curiosity are our most trusted companions. In this great debate, we've journeyed through ancient beliefs and modern theories, but what does it all mean? Well, we've delved into the heart of the flat Earth theory, unraveling its historical origins and modern-day proponents. We've looked at the spherical Earth theory, tracing its roots from ancient Greek philosophers to today's scientific consensus. And we've seen these two theories clash head-on, each vying for supremacy in our understanding of our world. Throughout this journey, we've witnessed the power of ideas and the importance of critical thinking. We've observed how beliefs can shape our perception of reality, and how evidence can challenge our preconceived notions. It's a testament to the human spirit's unyielding quest for knowledge, a quest that's as old as humanity itself. This debate is not just about the shape of the Earth, it's a reflection of our collective curiosity, a testament to the human capacity for inquiry and discovery. It's a reminder that the pursuit of truth is a journey, not a destination. It's a journey that requires us to question, to explore, and to learn. It's also a reminder that respect for different perspectives is vital in this pursuit. Whether we believe in a flat Earth or a spherical one, we must remember that our beliefs are born out of our individual experiences and understanding. We must be open to dialogue, to discussion, and to the possibility that we could be wrong. In the end, the shape of the Earth, whether flat or spherical, is but one facet of our fascinating world. There's a universe of knowledge waiting to be discovered, a cosmos of mysteries waiting to be solved. It's a world that invites us to question, to explore, and to learn. So let's embark on this journey together. armed with curiosity and fueled by the desire to understand. Let's foster a spirit of open discussion and respect for different perspectives, because in this pursuit of truth, every question matters, every idea counts, and every perspective is a lens through which we can see the world anew. Whether flat or spherical, our world remains a fascinating place, inviting us to keep questioning, keep exploring, and most importantly, keep learning.